Coastal communities are in trouble. You've probably heard about beaches shrinking and towns flooding more often as sea levels rise due to climate change. So you might expect that to be catastrophic for tiny, low-lying islands in the middle of the ocean. And yeah, for decades, researchers have expected rising seas to swallow entire islands, especially those near coral reefs. But that is not what's happening. Instead, most of these islands have stayed the same size, and some of them have gotten bigger. So let's talk about the weird reasons why, and how we can keep it that way. First, we need to talk about atolls, not the fees that you pay while you drive on the highway. An atoll is a ring-shaped coral reef structure with islands peaking above the surface. Atolls can have up to several hundred islands, most of which are smaller than 10 square kilometers and only a few thousand years old. When you step foot onto a stunning white sand beach on one of these islands, you are literally standing on the skeletal remains of sea creatures. Coral, mollusks, and other organisms produce calcium carbonate, which becomes the sediment that forms the islands. Globally, the average sea level has risen by more than 20 centimeters since 1880, and sea levels are rising near these atolls even faster than they are elsewhere, and they could rise by another 60 to 70 centimeters by 2100. That's a pretty big deal, given that most islands in atolls are only 1 to 5 meters above the water. In 2010, researchers published the first quantitative analysis of how atoll islands have changed in shape in recent decades, and they found something really weird. Most of the islands were staying the same size, and some were growing. Imagine pouring too much water on your potted plants and then seeing the soil rise up somehow instead of getting submerged. That's basically what the data showed. And that first study wasn't a fluke. In 2018, an analysis of 709 islands across 30 atolls in the Pacific and Indian Oceans found that nearly 3/4 of the islands were stable in size. 15% got bigger and only 11% got smaller. None of the islands larger than 1/10 of a square kilometer shrunk. But just because an island stays the same size does not mean the shoreline isn't changing. For example, one island in the Maldives is gradually moving south and rotating as the northeastern shoreline erodes and more sand arrives in the northwestern and southern shorelines. And this has to do with what these islands really are. Remember, atoll islands are not solid rock. They are piles of dead coral stuff, and the dead coral that forms them can be moved around. In other words, waves shape atolls, and atolls shape waves. Let's say a big wave heading east hits the western edge of an atoll. Like a conveyor belt, the wave will pick up sediment from the coral factory below the island surface and then dump some of it on the western shores of the first islands it hits. Then the wave will continue through the gaps between the islands, weaker but still powerful. And when the wave hits islands farther east in the atoll, it will deliver sediment to their western shores too. The direction and strength of the waves depends on the direction and strength of the wind, which can vary throughout the year. In the Maldives, for instance, the winds blow from the west for about 8 months, and then from the east for about another 4 months, and the waves are up to 5 times stronger when the winds blow from the west. These patterns can cause seasonal variations in how much sediment is deposited and where, which ultimately plays a key part in determining where the islands formed in the first place. But seasonal wave patterns are not the only architect directing the island building process. Storms like cyclones can erode shorelines by washing sand out to sea, or build them up by breaking off coral rubble from the reefs. And human infrastructure comes into play too. Just look at what happened in 2021 in the Maldives. On the island of Himandu, a new harbor prevented waves from shipping sand to a nearby beach. As the beach eroded, they found a gnarly surprise: dead bodies from a forgotten burial ground. Not a great vibe for the resident who wanted to build a hotel there. Between all these factors, there's no clear trend in which part of atoll islands are shrinking and which parts are growing, but the deposits of sediment are keeping them above water. Even without climate change, these islands are always shape-shifting. A recent study suggested that over the past 1,000+ years, one island's shoreline has meandered as much as 200 meters. Now, this is not to say that it's all sunshine and rainbows for these islands. For one thing, climate change is causing causing more intense tropical cyclones, and sea level rise threatens the supply of drinkable groundwater in atolls. A lot about the future of atolls is uncertain, but the bottom line is that they do have a future. Most atoll islands aren't gonna vanish beneath the waves, because the coral factory continues manufacturing new sediment and shipping it to the shores. They add an average of 0.1 cubic meters of sand per meter of coastline every year, which may not sound like a lot, but it is. So we need to make sure that humans support this natural process rather than getting in the way. By protecting and restoring reef ecosystems, we can ensure that they produce enough new sediment. Plus, when the sediment arrives, we need vegetation to keep it from eroding away. Diverse native plants are great at holding on to soil and sand, much better than a monoculture of coconut palms. And when we build infrastructure, we need to design it in a way that maintains the conveyor belt of sediment from sea to shore. All of that will protect these atolls for years to come and avoid surprise dead bodies washing out, which is also a bonus.